Hello everyone, welcome to this video. Today we will be talking about the gamma and beta functions. Before that, everyone who is preparing for ISI and JE 2026 may check out for the following. As you can see, this is what you will have once you subscribe back. Now, the links are in the description and the channel page. This can be only attempted through the Android application, whose link is in the channel. You will have a set of pre-recorded contents as well, like this, some extra materials, like this, and of course, there will be live sessions twice a week, and those live sessions will be very disciplined. So this course would be for 8 months. So basically, you have to be ready to spend your time on this course so that you can keep up with it. You can attend the two sessions, do the homework, and try and keep up with whatever's happening. So if you are preparing, to consider joining and just join the Telegram group and let me know. Okay. Okay. Back to the video. Now, what you just saw, that can be joined via the Telegram link provided in the description, and you can also download the app directly, which is also provided in the description. So, whenever you join, it's fine because you will always be able to see the previous sessions as well, and they are all available to you at every time. So, it does not really matter for that much. And the course and everything and the pricing is also given. So, let's begin for this session. Gamma and beta, right? First of all, what is a gamma function? Now, a gamma function is defined in this way. We write gamma of s. This is the symbol for gamma of s, and it is defined as an integral from 0 to positive infinity, x to the power s minus 1, e to the power minus x dx. This is called the gamma function. Now, this is defined for s greater than 0. Also, a very interesting thing about this is that gamma of s is equals to s minus 1 factorial. And this happens when s is greater than equals to 1 and s is a natural number. So that is when we define this. But for fancy reasons and for fancy stuff, we also sometimes use values of s which are less than 1 but greater than 0. And we can define, fractional part factorials using that. So that's just fancy, but it does not really have much meaning, of course. Now, this is the gamma function. Now, what is the use of this gamma function? First of all, there are many questions which will appear in this format, many integration problems, and gamma and beta are something which is used in almost every section of maths and physics, even other science fields like computer science as well. And these are very fundamental because of the following. The properties is as follows, that gamma of s plus 1 is equals to s times gamma of s. Okay. Now, this is a property which you can establish directly by using integration by parts. You can do the integration by parts on this integral, and you will end up at this. A very basic property would be gamma of 0. Gamma of 1. 0 is not defined. Gamma of 0, by the way, is infinity. If you were wondering, it is basically infinity. Gamma of 1 would be nothing but the integral 0 to positive infinity e to the power minus x dx. That is equals to 1. And you can show that gamma of s plus 1 in this manner will keep reducing, right? If s is a natural number, of course, it will keep reducing like this, gamma of s minus 1, and then so on and so forth. And ultimately, it will reach the point where you have ultimately reached 1 gamma 1. But since gamma 1 is 1, this is nothing but 1 to s product, which is nothing but s factorial. That is how you get that property using recursion. Okay. Gamma has various different ways of representing itself. So this is an integral which has been asked. The format of this integral in JEE Mains, JEE Advanced, both of the examinations, and also in ISI BSTAT examinations as well. Of course, that is not required when you are actually solving for it. But knowing this function entirely makes a difference because you immediately spot what's going to happen in that function. Okay. Now let's see what a beta function would look like. Beta function, and this is important because beta can be defined in terms of gamma. That is why we are studying the gamma first and then the beta. Okay, the beta function. Now beta function is like this: beta of a comma b. It has two parameters. It is defined also as an integral, x to the power a minus 1, 1 minus x whole to the power b minus 1 dx. Okay, so this is the beta function. Now I will not show you the proof right here. I would really ask you to try it on your own if you can. It can be represented as gamma of A times gamma of b divided by gamma of a plus b. And if a and b are natural numbers, you can write this as a minus 1 factorial, b minus 1 factorial, whole divided by a plus b minus 1 factorial. Make sense? Okay. So an example would be good. So suppose you have 0 to 1 x squared, 1 minus x whole to the power 100 dx. What would be the answer of this question? This would simply be, if you first we need to convert it to a beta function, right? So x to the power 3 minus 1, 1 minus x whole to the power 101 minus 1 dx. Now we see the parameters a and b. So a is 3 and b is 101, correct? This would mean this is gamma of 3, gamma of 100, and then gamma of 100 plus 3. But since these are natural numbers, we can simply write 2 factorial, 99 factorial divided by 100, so not 103, actually 102 factorial. And you can cancel them off, right? You know that 102 factorial can be written as 102 times 101 times 100 times 99 factorial. Again, the beta function can also be represented in a similar form, which is this 0 to positive infinity, x to the power a minus 1 whole by 1 plus x whole to the power a plus b. This is also equal to the beta function, and so is this 0 to positive infinity, x to the power b minus 1 whole by 1 plus x whole to the power a plus b dx. Both of these equal the beta function. Good. Okay. Also, kind of integral, which is this 0 to pi by 2 sine x whole to the power m. So let me just write it like this: sine x whole to the power m and cos x whole to the power m dx can be represented in terms of beta of something. It's basically m plus 1 by 2 and n plus 1 by 2. I'm not going to derive it. And there is a half outside as well. So I think this is like this, but I may be wrong. But yeah, you can do this. And how can you do this? You can do this by using the substitution sin x equals to t. You can do this. So there are so many applications. So there are so many applications of the gamma and beta functions. Okay. So that being said, that would be the theory portion. And some special values. I should mention the very special Euler's reflection formula actually uh, before concluding that. So gamma of s, if this gamma of s can be written like this, gamma of s times gamma of 1 minus s. Of course, s is between 0 to 1. Only then can we write this as pi upon sine of pi s, where 0 less than s less than 1. This is called the Euler's reflection formula. Euler's reflection formula. A very nice corollary of this is the following, which is gamma of half. If you put s equals to half, it becomes gamma of half square equals to pi, which in turn gives you gamma of half is equals to root pi. And if you're fancy, you can write minus half factorial is equals to root pi. So yeah, so we can do a lot of things using the gamma and beta functions. So it's something that you can just memorize as a formula, maybe. And if needed, you can just apply it as a tool for now. So that should be all. So check out the description if you want to join the course. So be hurry up actually. I would really love all of you to attend all the live sessions. And on YouTube, we will obviously continue doing the live sessions as usual. Okay, that should be all. Thank you for watching.